Hello, I'm Nicholas Bergeron. I'm here to talk about Lab 4 for Physics 2211. And in this lab, we went over the oscillation of a spring. So as we can see in this video from Tracker, I will play it now. I started from the 4 seconds because he just moved it back, so this doesn't really mean anything. So yeah, as we can see, our spring is slowly oscillating back and forth. And here is our x and x graph for x versus time graph. So what we did is using this graph from Tracker, I made a code, or we used the code basis to have a model versus experimental graph for both the x position and the y position. So the first thing, and also of course, our change in energy versus time. And what this shows you is that it shows how the energy is being how conservation of energy is not like being broken by how we're doing this, and that everything that we are doing, it does obey the law of conservation versus energy. So as we can see, sorry about that. As we can see, all of our energy is being converted, so from kinetic to potential and potential to kinetic for our model right here. And As you can see, we are having changes of energy. So we are changing from kinetic to potential and potential to kinetic, as shown by this graph. They are oscillating because when it's all kinetic, it is no potential, and vice versa. But since this is always in motion, there are always going to be some potential energy, just because of how the spring is orientated, and because of the force of gravity. So, and also, and another important part is looking at the periods of oscillation. So for the x position, the period of oscillation was, hold up, I had it on my calculator because I can't do quick math. It was 1.61 seconds. So from peak to peak, 1.61 seconds. And for y, it was 1.53 seconds. So a very close difference, but not an exact difference, which is to be expected, because it is a model, or not. I'm sorry, not a model. It is an experimental thing, and in experiments, nothing is ever 100% perfect. So there's probably some slight differences in how the person that did the experiment put the moved like the spring up. So there's just going to be slight differences, and that's just because there's always experimental issues. So which isn't a very surprising thing. But we can also see the differences between our model and our experiment. And I really liked this graph when I finished coding, and it looked like this, because as we can see, as time goes on, the graphs get more, or not. Yes, the graphs have greater variation with each other, and that is because of the air friction. So as we can see, some of that energy, it of course, it's an experimental, it is an actual experiment, not a model. With friction, some of that energy is being converted from kinetic to friction, or to heat due to friction. Yeah, sorry. So it's being lost as heat energy. So we can see this in the x position, which and the y as well, but it is much easier to see this in the x position. So it was really cool. Well, I guess cool is not the right word, but it was very interesting to see how in our graph we have a clear delineation. As time goes on, the two models become less and less exact. So that, I believe, is everything. Let's see. Yep, I oscillation. So yes, that should be. Yes. So that is everything. So as we can see, change in energy for our model, change in energy is 0, because it is being converted from kinetic to potential and vice versa. So yep, that was lab number 4 for Physics 2211. Thanks for watching.